Hey guys, it's Miss Adams again, and we're still looking at lesson 6B.4, solving quadratics by square roots. So up until this point, we have been looking at solving by the square root method when we have rational roots. So these are whole numbers, they can be terminating decimals, they can be repeating decimals, but all of these are rational roots. Let's see what happens when we have irrational roots. So example 3 says y equals 7x squared minus 77. First off, this is in standard form, so the key characteristic is our y-intercept. So we look at the c value. Now I've got 0, negative 77 as my y-intercept. If we were to graph that, that would be a really ugly, disgusting graph. But it's fine. It happens. Let's see what happens when we solve for our roots here. So I have y equals 7x squared minus 77. With standard form, we can go directly into setting this equal to 0. So I have 0 equals 7x squared minus 77. And we're trying to isolate just x squared in this case. So I'm going to add 77 to both sides. So I have 77 equals 7x squared. And then I'm going to divide both sides by 7. So that gives me 11 equals x squared. Now I'm going to take I'm going on to the third step of taking the square root of both sides. Well, I know that the square root of 11 is not rational. It doesn't simplify. 11 is a prime number. So I'm going to leave that as just plus or minus the square root of 11. And then the square root of x squared is just x. So that is as far as we can go to keep it as the simplified version. X equals plus or minus the square root of 11. So our solutions are x equals square root of 11 and x equals negative square root of 11. And those are irrational. So our x-intercepts we can just write as the square root of 11, 0, and negative square root of 11, 0. Now, if you were asked to graph these, you could use your calculator, put those into the calculator, and convert that square root of 11 into a decimal to find the decimal value of that irrational root. Now let's go on to the u-try problem. It says f of x equals 3x squared minus 39. This is also in standard form. So our y-intercept is our key characteristic here. And we look at our c value, which is just negative 39. So our y-intercept is 0, negative 39. We're going to set f of x equal to 0. We're going to have 0 equals 3x squared minus 39. First step is to add 39 to both sides. So I have 39 equals 3x squared. But then we want to isolate our x squared, so I'm going to divide both sides by 3. So that gives us that x squared equals 13. I'm now going to take the square root of both sides to solve using the square root method. The square root of x squared just becomes x. And 13 is a prime number, so its radical cannot simplify any further. So I'm going to have x equals plus or minus the square root of 13. So our roots in this case are x equals positive square root of 13 and x equals negative square root of 13. And those are irrational. So your x-intercepts are at square root of 13, 0, and negative square root of 13, 0. So that's how we solve using the square root method for irrational in standard form. Let's look at what happens in vertex form. So there's a couple more steps that we have to take when it's in vertex form. First off, in vertex, our key characteristic is our vertex itself. So I go inside my parentheses, I look at that h value, change the sign. So that's going to give us a negative 7. And then I just take my k value, in this case is negative 9. Alright, so let's go ahead and set this equal to 0. So 0 equals 3/4 times x plus 7 squared minus 9. First step I want to do is add 9 to both sides. So 9 equals 3 over 4 multiplied by x plus 7 squared. Now I've got this fraction. There's a couple ways I could go about this. I could keep, change, flip. So that's multiplying fractions. I could just multiply both sides by the opposite of this fraction. So instead of 3/4, I would multiply both sides by 4/3. Or if we want to break it into two parts, that way you see each step, we can do it that way. So let's go ahead and multiply this whole equation by 4. That's going to eliminate our 4 on the bottom of our fraction there. And that 4 has to be distributed to each term. So 4 times 9 is going to give us 36. The 4 cancels out of the 3/4, so we're just left with our numerator of 3. And that's multiplied by x plus 7 squared. Since the x plus 7 squared is multiplied by the 3/4, we do not distribute the 4 into the x plus 7 itself. Then I'm going to divide both sides by 3 to isolate my squared expression in this case. 36 divided by 3 is going to give us 12. And that's going to be equal to x plus 7 squared. At this point, we can take the square root of both sides. The square root of 12 does reduce, because if I think of 12, I know the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. So that 3 and 4 is what we're going to use because 4 is a perfect square. That square root of 12 becomes the square root of 4 times the square root of 3, which is going to simplify to plus or minus 2 times the square root of 3. And that's going to be equal to our expression x plus 7. At this point, we're going to need to break this into two equations. I'm going to have x plus 7 equals a positive 2 times the square root of 3. And x plus 7 equals negative 2 times the square root of 3. And for both of these, I'm just going to subtract 7 from both sides. But we cannot combine a constant or a rational term with an irrational term for the simplified version. So I'm going to have x equals negative 7 plus 2 times the square root of 3 as my first solution. And then for my second solution, I have x equals negative 7 minus 2 times the square root of 3. So those are my two solutions. I'm going to write those there. And this is irrational because both of those contain an irrational term. And then my x-intercepts, I could plug it in the calculator and get the decimal form. Or I will definitely accept you just leaving it in its simplified term of negative 7 plus 2 times the square root of 3, comma 0, and negative 7 minus 2 times the square root of 3, comma 0. Let's look at this final u-try. So our first step always is to set our f of x equal to 0. So I'm going to have 0 equals 2/5 multiplied by x minus 4 squared minus 12. We can go ahead and identify our vertex. That's going to be negative h, which in this case is negative 4, so that becomes a positive 4, comma negative 12. All right, now we want to go about isolating our squared expression. So our first step is to add 12 to both sides. So I have 12 equals 2/5 multiplied by x minus 4 squared. And now we want to get rid of our fraction, so I'm going to multiply everything by the denominator. So everything gets multiplied by 5. 12 times 5 is 60. And that's going to leave our numerator of 2 multiplied by x minus 4 squared. And then divide both sides by 2. So 30 equals x minus 4 squared. Our next step will be to take the square root of both sides. So I have 30 equals x minus 4 squared. And we're going to take the square root of both sides. 30 in itself is not a perfect square. If I look at the factors of 30, I've got 1 times 30, and 5 times 6, and 2 times 15. None of those are perfect squares, so the square root of 30 remains as the radical square root of 30. So in this case, I'm going to have x minus 4 equals plus or minus the square root of 30. So I break this into two equations. X minus 4 equals positive square root of 30. And x minus 4 equals negative square root of 30. And in both of these, I'm going to add 4 to each side. And that is a rational term adding to an irrational term. So I've got x equals 4 plus the square root of 30 as my first solution. And x equals 4 minus the square root of 30 as my second solution. So those are also my roots. Those are irrational. And our x-intercepts are 4 plus the square root of 30, comma 0, and 4 minus the square root of 30, comma 0. And guys, that is lesson 6B.4, solving quadratics by the square roots. Let me know if you have any questions, comments, or concerns.